Hey everyone, this is Darshan Santar and welcome back to another video on differential calculus. In this video, we're going to be talking about graphing derivatives. Before we dive into the intricacies of that, however, I want to ask you to do this little warm-up exercise. I want you to just try to sketch or at least visualize what the tangent line would look like at the following points, 1, 2, and 3. So take a second, pause the video if you need to, and just do that, and we'll move from there. All right, so let's try this out. So at point 1, you're going to have a tangent line that looks something like this. Yeah, not perfect, but you get the idea. It intersects at that one point. Point 2, we're going to have something that looks like that. Kind of like that. Point 3 is going to be maybe something like that. Yeah. So those are our tangent lines. Okay. Now, let's take this to the next level. Based on what you drew, or what you visualized maybe, if you saw that, what can you say about the sign of f prime of x at each of those points? Now, before we go there, I'd just like to make one comment. What is another meaning of f prime of x? Well, f prime of x can also mean the slope of the tangent line. Okay. Bearing that in mind, I'd like just carry on. Okay, let's go over this together now. So the slope of the sign of the slope of the tangent line at each of these points. Okay, so at point 1, the tangent line is oriented downwards, right? It's oriented negatively. So therefore, we're going to have a negative slope, right? And think of this in terms of any line. If you had a line that was oriented downwards, then naturally you're going to have a negative slope. Now, look at this line, at this tangent line at point 2, it's oriented upwards, right? So it's going to be increasing. So therefore, we're going to have a positive slope. At point 3, however, we seem to have what looks like a horizontal tangent, which means there's no rate of change, and therefore we're going to have a slope of 0. Okay? So just some useful information. Now, before we move on to the next slide, I'd like you to just take a second and think about how all this information that we just derived relates to the behavior of the function f of x as a whole. Take a second, just think about that, and we're going to be talking about it in the next few slides here. All right, so now we're just going to go ahead and pick apart what we talked about in the warm-up activity. We're just going to analyze it and sort of relate this to what we're going to be doing today. So on intervals where f of x is decreasing, okay, where it's decreasing, the tangent line is going to point downward. And where can you see it on this graph? Well, look at the function, look at f of x at point 1. Well, it's clearly decreasing, right? You can see it's on a negative trend. And you could see this for any point on this relative interval, not just point 1. If you drew a tangent line over there, you'd also see that it's oriented negatively. Or even over there, you'd see that it's oriented negatively. It's oriented downwards, okay? So you can't have a tangent line that's going to be perfectly down like this, because that would be undefined. But you can have a tangent line that's going to be oriented downward like this, okay? Now, what about the slope of that tangent line, i.e. f prime of x? That's going to be negative, right? As you can see, because it's oriented downward, it's going to be negative, okay? What about when f of x is increasing? Well, the tangent line is going to point upward, right? As we just saw, like at point 2 and points near it where the function is increasing, you're going to have a tangent line that looks up like that, okay? Now, what about the sign of that slope? What about the slope of the tangent line at that point? It's going to be a positive number, right? Just because the function is increasing, okay? So just to summarize, wherever f of x, the function f of x, is decreasing, you're going to have a tangent line that points downwards, and your derivative is going to be negative, okay? Wherever f of x is increasing, okay, wherever f of x is increasing, your tangent line is going to point upward, and you're going to have a positive slope, okay? Just to sum it up really quickly. So here's a little bit of a problem-solving strategy. This is just going to be the final step that ties together what we just talked about to actually going ahead and graphing graphing a derivative. So here's what you do. First thing you do is you're going to find points where f prime of x equal to 0. Okay, that's your first step. These are actually things that are called critical points. Points where f prime of x equals 0. Critical points are a lot more important in some of the more advanced graphical analysis we're going to be doing in a few videos down the road. But for now, we're just going to say there are points where f prime of x equals 0. Okay? So once you have that, you're going to go ahead and estimate the sign of f prime of x in between. You're just going to use the graph of f of x and try to see what f prime of x is doing in between those points. And then you're going to go ahead and sketch. Okay? So how does this work? Well, if you just take a graph like this, for example, right? Take a graph like this that does like some crazy stuff. So the points where you have a zero slope or a horizontal tangent, those are places where the graph happens to switch sign. They seem to be places where the graph switches sign, where it goes from positive to negative. Now that will not always be the case, right? There are going to be, like, if you had a graph like this that has a zero tangent line, but it still is going on the same way. But they are not only places where the graph seems to switch sign pretty often, or seems to switch from increasing to decreasing, but those are also places where f prime of x will hit the x-axis. Okay, so wherever you have a zero slope, those are places where the graph of f prime of x will hit the x-axis because it's going to be 0. Okay, so that's a little useful piece of information, and it's something that's going to be a real big deal later down the road. And the last little point I want to make is you want to exaggerate based on the actual behavior of your graph. So if you have a really steep slope, for example, a really steep negative slope, then you want to assign a really negative value to that slope. On the other hand, if you have a slope that's like this, it's decreasing, but not very rapidly, then you want to assign a less negative slope. So just use your intuition there and kind of make sure you are assigning the right values. Okay. But anyways, let's go ahead and wrap this up with a quick example. Okay, so now let's go ahead and do this little example to wrap up the video. So let's just go through our steps now before we even start. So first thing we're going to do is we're going to find the critical points, and to remind ourselves, those are just places where f prime of x equals 0. Now, if you have a function, there's a little bit more you can more rigorously find those points where f prime of x equals 0, but if you're just given a graph, it's easier to just sort of guesstimate using a tangent line. And that looks to me like these points, like right over there and right over there are places where I have horizontal tangent lines, or where my f prime of x is going to be 0. So therefore, I can sort of extrapolate that at these 2 points, my derivative is going to hit x equals 0. The graph of my derivative is going to hit the x-axis. All right. Now, let's sort of analyze what's going on in between. What's going on in between these points. Okay. All right. So everything to the left of this point here, okay, everything to the left. So on this entire interval, f of x is increasing, right? So let me just put that in a better place. So on this entire interval here, f of x is increasing, right? And therefore, f prime of x should be positive. As you can see, it's increasing, and therefore it's going to have a positive slope, okay? What about on this interval? Well, f prime of x is decreasing, right? And therefore, prime of x is going to be negative, right? Last but not least, in this interval here, f of x is increasing, and therefore f prime of x is going to be positive. Okay. Now, make sure you understand that none of this has anything to do with this actual sign of f of x. So f of x's sign, let me just use a different ink to phrase that in, does not matter. Okay, the sign of f of x does not matter. Like, you could take this entire graph and translate it up 50 units, it would be the exact same thing, regardless of whether this point was at over here or this point was over here, or you could translate it down 50 units. The graph of the derivative is going to be the same. Okay, this is actually a really key point that comes back in integral calculus, but anyways, for now, that's just, I just wanted to make that clear. So as you can see here, f of x is all negative until over here, but that doesn't matter for the sign of the derivative, right? The derivative only cares about increasing or decreasing. It does not care about the actual value of f of x. Sometimes that can be a bit confusing, so I just wanted to make that really clear. Okay, so now that we have that, we can go ahead and sketch. Okay, so now we can go ahead and sketch. But we need to make sure we also exaggerate correctly, okay? So over here to the left of this critical point here, f of x is really, it's increasing at a really rapid rate. As you can see, the point, it's almost an undefined tangent. So we're going to have a really high value here. I can't go any higher than that, so just you get the idea. So it would be really, really high, but as we're getting closer and closer to the critical value, it's getting closer and closer to zero, right? So we're gonna sort of be slowing down like that, right? And we hit zero as planned. Now on this interval, f of x is decreasing, so it's going to be negative. So as you can see, we're going to get more and more negative, but then we're going to get steadily less negative and hit zero again. So it's going to look something like this. So we're getting more and more negative, we're going more and more negative, but then we're starting to level off a bit. We're starting to get a little less negative, starting to get a little less negative, less negative, less negative, and then finally we hit zero. Okay, let's make that just a little clear curve. But yeah, so we're going to hit zero here. And then we're increasing again. So we're going to keep increasing, just keep increasing, just keep increasing. And it's getting larger and larger. It's not stopping, so we're just going to keep increasing, increasing, and increasing to eternity. And also, let me just label that this is going to be f prime of x. Okay? So that's how you'd graph a derivative. If you found this video helpful, please do like, share, subscribe, leave a comment, and check out some other videos. See you next time!